Hey everyone, we're going to start in about a minute. We're just waiting for everyone to join and then we'll start. Okay, cool. Hi everyone. Are you guys able to hear me? Just drop a quick yes or no in the chat. If I'm audible to everybody, say a yes or no in the chat, guys. Are you guys able to see my shared screen? Everyone? Is my shared screen visible to everybody? Okay, cool. So in the last class, we started preparing our location service. Remember, we started talking about location service altogether. Okay, and I gave you guys a task to maybe try to integrate Redis. How many of you guys actually tried to integrate Redis altogether? Anyone? Guys, did you try to integrate Redis altogether? Anybody? No one. Guys, nobody tried to integrate Redis. Like, nobody tried to integrate that API. Is there anyone who actually tried to maybe set up Redis? Okay, Shubham. What about rest of the people? I guess nobody was trying, right? Pretty strange. Guys, ideally, you should definitely try whatever we are doing. Try to set up Redis, but couldn't integrate. Okay, Yogesh. Okay. I'll buy that. Rest of the people? Okay, cool. So, let's start talking about this. Let's start talking about it. So we talked about the fact that we want to have an API, right? No problem, but we want to talk. We were talking about this architecture, right? Like, let me open Excalidraw. Okay, we talked about this architecture, right? That we want our client application to actually keep on sending our request to the location service, and the location service should directly just populate this to the message queue. Now, later, this location service should be having a consumer that should collect the request from the message queue and populate it to our MongoDB server if we want. Or if we are not using MongoDB and we are using a relatively faster service like something like Redis, then we can just directly put into Redis as well. We talked about both of these architectures, right? Remember? Okay, so we'll go with the first solution first. We'll try to integrate an API with Redis, and later maybe we can also try to integrate MongoDB along with some message queues. Make sense, everyone? Okay, cool. Now, you should be having Redis already installed in your system. I have Redis installed in mine. if you will just go like this and you do Redis server, you can see Redis is up and running in my machine. Okay, so there are a couple of client libraries for Redis that you can actually use in order to integrate Redis properly in your corresponding project. One of them is called as Jedis. Okay, you can see Jedis is a Java client for Redis designed for performance and ease of use. You can see even the official docs of redis.io talks about Jedis. Okay, and if you want to install Jedis, you can see it's a pretty simple and straightforward dependency implementation. So I'll go to build.gradle and I will add that probably here. Okay, so you can see we also had a Spring Boot starter data Redis, or maybe we can use something like Jedis. Any one of them can actually work for us. You can see I'm using Jedis for now. Okay, cool. Okay, once you have Jedis with you, now you can actually start using Jedis, right? Now, if I show you the basic set of APIs for actually adding and storing things, okay. If I go back here, Jedis GitHub, okay. And you can see, you can just set up a host like where exactly your Redis client is actually present. And then you can just keep on adding your key value pairs. This is pretty simple and straightforward altogether. Okay, so let's do that. So for our Spring Boot project, what we have to first of all do is we need to create a new package. I'll call it as configurations. Okay, inside the configuration package, I'll create a new Java class and I will call it as Redis config. Okay, so now I'll annotate this class with @configuration. Okay, and you can check like integrate Jedis with Spring Boot. You'll find a similar kind of an implementation altogether. Okay, so you can see you can set up and install Jedis. Then you have to add the host and the port, and you can see you have to write kind of like this this kind of a Redis configuration class. If you carefully see inside this Redis configuration class, what you do is you set up the Redis like host name and the port. And here you also set up like what kind of a connection factory you want to use, right? And you can add some more configurations here as well. So we are also going to do something similar to that. Okay. So first of all, I'll create a function public Redis connection factory. Okay. Redis connection factory. Okay, so when we will initialize Redis, it will require the Redis connection factory. Okay, now a lot of time you will hear this word factory. Okay, this comes from the factory design pattern. So factory is kind of like some place where you are going to create something, right? That's your normal factories, right? So that's the same use case for factory design pattern as well. I guess there is one adapter lecture pending, right? I have not yet uploaded that. So today we are uploading a couple of lectures of networks as well. So one lecture on factory and one lecture on adapter design pattern. Both of them I'll try to make sure we upload by today. Okay, so you can learn how you can create your own factories. There is two type of factory, one abstract factory pattern and one normal factory pattern. But on and on, you can assume that wherever you have a factory, it is going to create some kind of an object. And this object is mainly the Redis connection object here. Okay, and you can annotate it with bean so that at any point of time, if somebody creates a Redis connection factory object, they come to this particular place. And what we can do is we can say return new Redis connection factory. So whenever you are going to have a Redis connection factory, this is an interface. If you will see, this is an interface. And the implementation of this interface has been done inside the Redis connection factory altogether. Okay. Now what you can actually do is you can come to your application.properties. And here you can say spring.redis.host. Okay. I guess it's spring.data.redis.host. Let's quickly check what does this say. I guess it should be just host. Okay. And you can say local host. You can say spring.redis.port. And you can mention the port. You can see on my machine. What's the port? The port is 6379. Okay. 6379. Okay. And looks like this is deprecated. Let's see how old is this. 2023 only. You can see pretty recently looks like they have deprecated this. So we can replace this with data.redis.host. In case you don't want to configure this here, you can actually configure it directly here as well, just like how they have done. You can see set host name, set port. You can even do this, right? If you don't want to configure it here. Okay. So any of the things will work. Okay. So for now, I'm commenting these two out. Let's first of all try it here only. I'll copy this whole part and paste it here. Okay. Pretty simple configuration we are actually doing. Make sense? And you can see even this part they are actually saying is deprecated. You should technically try to set it using the configuration. But again, any of the two things for now you can actually use. Make sense, guys? We can even check. We can even come and Google. We can say spring.redis.host deprecated. Okay. So you can see this is deprecated. So these are a couple of newer ways to actually set up things, right, for JDIS. And we can also go to the JDIS official documentation, JDIS, right? We can go to this official docs that is given by Redis only. And if you carefully see, once again, let's go with JDIS with Spring Boot. Okay. It's a one-time configuration. So let's see. So you can see Redis conf, you can see we have to create a Redis configuration, and you can see here, they are also setting up the host and the port, right? So we are also doing this. We are also setting up the host and port directly here. Any of the few things that you can do. Okay. And then once you have done this, once you have actually set up your Redis connection factory, the next thing that you are expected to do is, you are expected to create one more bean of public Redis template. Okay. What is this Redis template? This Redis template is going to define what type of a key value pair you are going to store, right? So in our case, we are going to store string, string, for example. Okay. And we'll say Redis template. Okay. So here you are going to define that what should be the overall template. You can read about Redis template. If you go here, you can see it's a helper class that simplifies the Redis data access. It performs automatic serialization and deserialization between the given object and the underlying binary data in the Redis store. So when you're going to give it a key value pair, it will do automatic serialization and deserialization to whatever is more compatible with Redis. Are you able to get this point? Okay. So what we can do is you can say Redis template of type string, string. Redis template is equals to new Redis template. Okay. And then you can say Redis template dot set connection factory. And where we are going to bring the connection factory from? We are going to bring the connection factory from Redis connection factory. And then we'll say Redis template dot set key serializer, right? This is going to serialize the key into the corresponding binary format for Redis. And we will say new. And what is the key type? String. So there is a inbuilt string key serializer object. Are you able to get this point? Okay. So we can just do this. Okay. So let's remove this. We don't need the Jackson serializer. We will say, I guess there is one inside Spring Data Redis. One second. Dot Redis dot serializer dot string Redis serializer. Okay, this is the one that we are going to do. Okay, let's see why it is throwing an error. String Redis. Oh, my bad. This is string Redis serializer. This is string Redis serializer. Got it? And same serializer we want for the value as well. Set value serializer, and we'll say return Redis template. So you can say it's a one-time configuration. What is this configuration saying? That whenever you have to get the Redis connection, you are going to get the Redis connection from here. And the key and the value pair needs a serialization technique. So based on what type of a data you have, you are going to pass that kind of a serialization strategy. Are you able to get this point? So it's kind of like passing a strategy altogether here, that what kind of a serialization strategy do you need for the key and the value? If the key, or let's say if the value is something else, then you need a different serialization strategy. Are you able to get this point? So you can say this is a direct application of the strategy design pattern altogether. Are you guys able to get this point? So throughout Spring Boot journey, yeah, like you will find a lot of design patterns going on here and there. is Redis, we are going to set up same as Redis cache, or Redis is different NoSQL? As Kaustubh, I already answered this question in the last class. Redis provides a lot of services. Redis overall is a NoSQL DB, which is kind of like that works in the manner of a cache. So it's not like, it's not going to store too much of this like data, like you can't store like terabytes of data here. It's kind of like that. It's a club of a couple of services that it provides. It can also act as a queue as well. Are you able to get this point? Cool. So you can see this is the Redis config. Let's try to run the service and see if everything is good and up and running. 1 second. It says it is not able to find the snapshot. Did we make some changes in the entity service? Let's quickly take a look. Build.gradle. Let's change. I guess we made some entity changes, right? We didn't publish it. Okay. Let's publish the 005 version to Maven local. Okay. And let's go here. Let's make it 005 snapshot. Refresh. It's not able to find it. Just a second. Why is that? Uh, 005 snapshot Uber project entity service. What's going on? 1 second. Let's copy this from here. Let's see if the auth service is working properly. Let's refresh in the auth service as well and run it. Yeah, auth service is working all good and fine. Let's copy this. Maybe we copied something wrong. Okay, this is same. Interesting. Oh, I guess I know the issue, probably. If I go to application.properties, we need this data source and everything, right? I guess this part, but 1 second, we just need the classes. And yeah, we will need the data source because if you go here, we have, we didn't have the Spring Data JPA. Can you guys see? We don't have the Spring Data JPA and everything, and it's trying to access the entity classes and everything. So we need all of that. So let's bring that from here. So Spring Data JPA. We will need this because we will be accessing these entity classes and everything, right? So let's refresh that. And it says could not find our snapshot. Interesting. We have the entity service here. Uber project location service. Okay, let's do a clean. Let's do a build clean once. Let's do a project cleanup. Okay. And let's see what all we have. Com.example, we are not able to see, right? Okay. So let's rebuild. Ah, 1 second. I believe I know the issue. Can you see? We have not mentioned that we need to also look for Maven local. Can you see? We have not mentioned that we need to look for Maven local also because our entity service is inside the Maven local. Okay, this was missing. Now, if I refresh, you can see now at least it is able to find. Let's see now what else is missing. Now you can see it requires the data source URL and everything because we have the Spring Data JPA and all together. Are you guys able to get this point? Everyone, is this point making sense? Everyone, are you able to understand why do you need a URL here inside this location service? Okay, so because we have Spring Data JPA here, installed, we will need this. But for now, I'm going to remove it again because currently we are not accessing anything inside our SQL DB. We just have Redis. Let's see if the Redis configuration is working fine or not. And now you can see after even removing this, this is coming up. And this is because we have our snapshot of Uber project running. 1 second, let me just quickly check. Okay, so let's bring the URL from here. Okay, we will still need it. So let's copy and 1 second, let's do one thing. If I remove this, just a second. If I remove this, rebuild. Okay, can you see without any library or anything? Can you see all of the things are working fine? We have our Redis configuration and everything working fine. Make sense? Okay, I've removed the entities as well because till the time we are not using an entity, we don't need it. Now, let's bring back the entity because if you carefully remember, inside our entity service, we have prepared an exact location kind of an object. Remember? Guys, do you remember? Okay. But do you think we will need this exact location entity? Because this exact location is going to be stored in the MySQL DB. Here, we are going to use Redis for storing our corresponding location. And that location we are going to just store in a key value pair kind of a DB that is Redis, right? So we are going to just store a key of driver ID and the value as the latitude and longitude. So again, we do not need this entity service at all. We are going to set up a separate altogether connection to Redis. And if you remember, we are going to expose one more API from the location service that is nearby drivers, and all other APIs who need to get access to the location of the drivers will actually make an API call here. We'll see that in the inter-service communication. So you can see these are the dependencies. We do not need as of now Spring Data GPA, and we do not also need the entity service library. And the Redis configuration more or less is looking good to me. Got it? Now what I'll do is very quickly, I'll come up here. I'll create a new package controllers. Okay, I'll create a new package controllers. And I will say, let's create a new Java class, location controller. Okay. And this is going to come up from REST controller. I believe everybody understands REST controller. And the request mapping, we are going to do as /API/location. Okay. And now what we are going to do is, we are going to write a method public and let's say response entity. For now, I'll keep it wildcard. Later, I'll introduce DTOs. Save driver location. Save driver location. Are you able to get this point, everyone? And in the request body, we can expect a DTO. So I'll create a new package DTO. Okay. And I'll create a new Java class and I will call it as save driver location request DTO. Okay. What we will expect in the save driver location? We will expect a driver ID, string driver ID. Apart from that, what else? We'll expect a double latitude, double longitude. Okay. And we will mark it as @getter, setter, builder, no args constructor, all args constructor. Make sense, guys? And we can make this as a double object. This should be latitude. Okay. So this is going to be the request DTO. And here we are going to say request body of type save driver location request GTO. Are you able to get this point, everyone? Okay. And let's say from here in the response entity, I'll keep the response entity of type Boolean, that it will return true if we are able to successfully store the driver location. Got it? Okay. And now, what we'll do is we are going to inject one interesting part that is going to be the Redis template. So I'll say private string Redis template, string Redis template. Okay, if you go to string Redis template, can you see string focused extension of Redis template? Since most of the operation against Redis are string based, this class provides a dedicated class that minimizes the configuration of a more generic template. Are you able to see? So this is a string Redis template. Inside this string Redis template, we have all the required configurations for the basic string based operation that we have to do inside Redis. Are you able to get this point? Okay, and this is extending from Redis template. Can you see this is extending from Redis template? So all the basic Redis template based requirement also are going to come up here. Okay, cool. Now, what we can do is we can say public location controller. Okay, and we are going to inject string Redis template, and we'll call it as this dot string Redis template as string Redis template. Let's import this DTO as well. Okay. Now, in this string Redis template, we have a function called as options for geo. So we'll say string Redis template dot ops for geo. If you see this function, ops for geo, this is coming for geo ops. Can you see? For any geolocation based operations, you have to use this geo operations object. Okay. So we will say this is going to return a geo operations object of type string comma string, because that's the key value pair we want. Make sense? And we will call it as geo ops. Make sense, guys? So we are going to use this geo operations object. And inside this geo operations object, you have a lot of properties. If you go here, can you see? You have a add property that you can add a key value pair. Are you able to get this point? Everyone, is this point making sense? Okay. So what can be the key? What can be the key? So we can store the key here like this. We can say private static final geo ops key is equals to drivers. Okay. So we are going to store all the driver based locations with the corresponding driver key. Are you guys able to get this point? All the driver based locations are going to go with the driver's key. So you can say driver geo ops key. Are you able to get this point? Okay. So if you carefully see geo operations, it takes a key and it takes a point object as the value. Can you see? It takes a point object. Everyone, can you guys see this? Okay. Or you can see this one. This is better. This is key and this is a geolocation of location. Okay. So this is the one that we are going to use. This is the one that we are going to use, that we are going to have a key, and corresponding to that key, we are going to store a geolocation object. If you go to the geolocation object, if you go to this geolocation object, can you see? You have the name of the object for which you want to store the geolocation, and corresponding to that, you store a point. Are you able to get this point? So if you see the geo operations Redis, okay, and if you go here, you can see Spring Data Redis geo operations. Okay, they have just the same documentation. Let me probably show you here. Okay, let's go to the official doc. Let's go to the official doc. Redis geo operation or geo spatial data. Okay, let me show you how they actually store it. Redis geospatial. Okay, so you can see that Redis geospatial index lets you store coordinates and search for them. Okay, so you can see there is a command called as geoadd. and there is a command called as geo search. So when we are going to add things here, we are going to use this same geo add command, but of course with the Java library altogether, right? So if you see, you do jedis.geoadd, and then you put a key that this location is for whom? This location is actually for whom? Are you able to get this point? So this is for bikes rentable. And then you give the corresponding latitude and longitude. Are you guys able to see this point? Okay. And if I go to this Java quick start, and if I go to this JDIS guide here, and if I go back, okay, they have not printed everything. Okay, let's copy this code. Let's copy this code and let's bring it here. Okay, now here you can see, this is the type of data that we want to store. First of all, you have to tell that this location belongs to which category. This location belongs to all the rentable bikes. Now, what is the location? Location is this latitude and longitude. And this location is of what? It is of the station 1, which is storing rentable bikes. Station 2, which is storing rentable bikes. Station 3. Similar kind of a stuff we will also need. That we will first of all tell that this is a collection of drivers. And then individual driver, driver 1, driver 2, driver 3, latitude and longitude we are going to give. So this ops key that mentions driver is kind of like this, that, okay, this is a collection of drivers. This is a collection of bikes rentable. And later you can do jedis.geosearch. Are you able to get this point? Okay, so that's what we are also doing here. So we'll create a geoops object. And we will say geoops.add. First of all, we'll pass the key. So we have the driver geoops key, and we'll say new redis geo command.geolocation. And here we will pass the dto.get driver ID. Okay, we'll get the driver ID. And corresponding to that, we are going to create a new point object. Inside this point object, we'll pass the latitude and longitude. So I'll say dto.get latitude, comma, dto.get longitude. And that's it. So let me bring it in new line. So I'll call this add method to this, which is going to call this one with the new point object. And this. Can you see? This is what we are actually doing. Okay. So again, mentioning, we say geoops.add, and then first argument is key. This key is going to tell that this is a collection of whose location. This is the collection of driver locations. Now for every location, you will give the latitude and longitude, which will be given in the form of a point object. And you will tell of which particular driver this location actually belongs to. Okay. And we will wrap it inside a try catch. In case there is any error, we will get that. Okay, so I'll wrap all of these things inside a try catch. Okay. And we'll say return new response entity of type, first of all, HTTP status code dot created. And here you can pass a Boolean true. Okay. And here we are going to say return false. And this is internal server error. Make sense, guys? So this API is looking good for us. Okay, cool. Now we are going to write one more API. And what should be the type of this API? This should be a post mapping. This should be a post mapping to /drivers. Got it? Now I'll create one get mapping. To /nearby/drivers. Okay. And here we are going to return a public list of string. This is going to be a public list of, let's say, driver ID, or maybe we can have a response entity of type list of string. Okay. Ideally, we should have a return response DTO, but okay. Get nearby drivers. Okay. Get nearby drivers. And again, we are going to have a request DTO coming into the picture. So I'll say nearby drivers request DTO. Okay. Just a second, guys. Let me put my system to charge. Okay, DTO. And inside this DTO, we will just get the latitude and the longitude. Okay, so I'll copy this from here and paste it here. And the getter setter also will get. Okay, cool. So we'll come here, and what's the DTO? So our DTO looks like @request body nearby driver DTO, nearby driver DTO. Okay, this is going to be the request. Make sense? So should we send driver object instead of string? Why do you need the whole driver object? We'll just send this ID, right? Remaining things about the driver is unnecessary for us. Because this service doesn't need to know anything about the driver, only the location of the driver. And if you just need to know the location of the driver, you just need to uniquely identify the driver. To uniquely identify the driver, you just need the driver ID. That's it. Got it? Cool. Now, again, we are going to create a geo operations object. This one. Okay. And we have a distance object that we can create. Distance is equals to new distance. Okay. And this distance object is going to be based on radius. Right. Now, what should be the radius, guys? What should be the radius that we should look for? Anyone? So if before we go there, you can see when you do a geo search, you mention a radius here, and then you mention the geo unit in kilometers, right? Or you can do meters also or anything. Okay. And if you do go to this distance object, you can see you can give a double value and a corresponding metric. So I'll create a radius. I'll say private static final double search radius is equals to 5.4. Got it? And we will say search radius. And what should be the metric? The metric should be metrics dot kilometers. Are you able to get this point? And we'll be having a distance object. Make sense? Everyone, is this point making sense? Now, this is going to define that, okay, we need to do a search in the 5 kilometer radius. Now, this 5 kilometer radius that we have to search, we are going to search in a circular fashion, right? There should be a circular, like there should be a circle with the radius as 5 kilometer and diameter as 10. And within that circle, whatever are the set of drivers present, we will query all of them. So there is a circle object that you can create. Circle within is equals to new circle. And inside this circle, you can give the center of the circle. Like how do you define a circle? You have to give the center of the circle and the radius of the circle. So I'll create a new point object. And inside that point object, we will get the latitude and the longitude. And then we'll give the radius of the circle, right? Radius of the circle, you have to give it in the form of the distance object. Are you able to get this point? You might be thinking, why do you need to give radius of the circle in the form of distance? Because this distance object is kind of like a end-to-end entity. This doesn't have just the scalar value, but it also has the units. That this is a 5 kilometer distance or a 5 meter distance. Just think about it. If you have to create a distance entity, you will not only have the scalar value, right? You will also have the unit. So this distance object has the unit as well. Okay. You can also call it as radius. And mark it as radius just for better reading. Got it? So now you have a circle, and within this circle, you are going to search. Are you able to get this point? So how do you search? You can say geoops of dot radius, then you pass driver geoops key, and you pass the circle object. Okay. So what it is going to do, it is going to look for all the drivers which are within 5 kilometer range of this particular point. Are you able to get this point? And what it is going to return us? This actually returns a geo result object. And what will be the type of the geo result object? It is of type Redis geo commands, right? And Redis geo command dot geolocation of type string comma string, right? And just string, because it is going to give us one single end-to-end object results. Are you able to get this point? Okay. And you can again read about all of this in the Spring Redis guide. Okay. You can see. So Geo, one second. Spring Redis, Geo Ops. Sorry, Geo Ops. Okay. You can see Redis Geo commands. And this is the whole class. Okay, one second. Let's say Redis for geospatial data. Okay, you can like search for the docs. Redis geospatial data and geo add. Okay. And if you go here, or you can see they already, oh, by default only they have given the Redis commands only. Can you see? So if you find our location within the 5 kilometer range, you can see you have given a coordinate, you have given a kilometer and the unit. And then you are going to do, you can either go for this as well. You can either go for this as well, right? You can stream on the geo radius response as well. This is something also that you can do. So if I go to Redis guide and if I go to geo, one second, kilometer. Okay, so they have not given it here. Maybe you have to refer to some official Redis docs only, but yeah, like you can use any one of the two things. This is one way in which you can actually find the corresponding set of drivers, and then we'll have a response. I'll say list of, one second, list of string drivers is equals to new array list. Okay. And we'll say for geolocation, or I would say geo result of this particular type. Okay. Result in results, because it's a list, right? Result in results, we'll say drivers dot add result dot get content. I guess there is, you can see there is dot get content function, and inside get content, let's see what is get content going to return us. It's going to return us a geo result of list. Okay. And let's see, this is geo results. Okay. So one second, nearby drivers, where's our controller? This is the controller. Or let's do one thing. This is geo results, right? So this should be of type geo result. There's an individual. Yeah, this should be of type geo result. You can see there's a singular and a plural object. This is something that you have to keep in mind. Dot get content dot get name. Can you see this name is going to be the corresponding driver ID for us? I'll say drivers dot add. Sorry, we have already done this driver dot add. No point of doing it again. Yep, you can see. So we're going to just loop over drivers, and then we are going to return new response entity of drivers, comma, HTTP status.ok. And we're going to wrap everything inside try catch so that we can look for exceptions. Okay, I'll cut all of this and paste it. It's just a set of inbuilt library function that you have to use, and that's it. Copy, paste, and this should be a new array list. We're going to send an empty array list altogether. Looks good, right? Looks good. Everyone, is this point making sense? Okay. Now let's run this first of all service. Okay, so the service is up. I'll open Postman. And what I'll do is I can maybe do one thing. I can take the data from here, because you can see these are the latitude and longitude that they are actually sending, right? And then they try to find it in within this particular kilometer range. So let's try to use this data only. Okay. Sir, but if we want to render location on the map on the UI, then we want to send locations also, right? Like Uber, Ola. Yes. Yes. In that case, you want, like, again, that depends. Like if you want to like start implementing the UI, then you can maybe store that as well. Like fair point, Shubham. You can even return that. Maybe we'll modify, but let's see. First of all, let's go to Postman. I'll modify that request, no problem. Instead of just sending driver ID, let's send the driver location also. And let's get Postman from here. Are you able to get this point, guys? What is the connection object? Like, what is this connection factory? Then there is a geo operations object. Internally, how the data is being stored. What is this key representing? What is this point representing? What is this distance representing? Why do you have a circle? This is the exact query. And then on the result of the query, you are going to just keep on iterating. There are other methods as well. For example, instead of get name, you can say get point. If you do get point, you will also get the driver's point. Are you able to get this point? So you can even do that. But for now, I'll just do get name. Later, I'll modify this request. Don't worry. But we'll come back to Postman. I'll say new collection. Uber location service. New request. Okay, where is the server? What's the port of the server, guys? One second. It's 8080. I don't want 8080. Let's do one thing. Let's change the port to 7477 maybe. Double seven. Let's change it to 7777. Let's run it again. And you can see now it's up on 7777. So I'll say localhost 7777. Okay. I'll set this as a variable. Server URL. Scope is going to be this particular collection. Save it as a variable. Okay. And we're going to make a post request. We're going to make a post request to, let's see how the controller we have prepared. This is /API/location, guys. So /API/location. And after that, it's a post request to /drivers. Okay, this is going to store driver location. I'll create a raw JSON. Okay. And we want a driver ID, like how the object is going to look like. These are the properties. So we need a driver ID. Okay. I'll just quickly check what all drivers do we have. Data source, MySQL. User is root. Password is mac@local. 1, 2, 3, 4, 5. Database is 1 second. Uber DB local. Okay, test connection. Apply. And okay, cool. So we have Uber DB local. Let's see what all drivers do we have. Uber DB local drivers. So we'll create a new query. Select star from driver. Oh, we don't have any driver. Maybe we can sign up a couple of drivers later. But for now, maybe I can just store the driver ID, let's say as maybe 1 and latitude as, let's get the latitude from here. Okay. This can be 1 latitude and longitude as this one. Okay. Cool. Let's see if the API is working or not. Send it. And you can see it returned true. That means it was able to save everything properly. So we have stored the first latitude and longitude. Then let's take this one. Okay. By the time I'm creating this data, can anybody find any tool on which we can maybe plot latitude and longitude? Can you guys find something on the internet? By the time I'm creating this data. Okay, so I'll make 4 of them, 3 directly from here and 1 more I'll create. Send it. So you can see 3 data pointers I've created. Let's see. Latitude, longitude, finder. Okay. So let's put the longitude here and latitude here. Okay, let's see what's this location is looking like. Find. Okay, this is from location to latitude, longitude, I guess. Once again, longitude to address. This is the latitude and this is the longitude. Convert. Oh, it says invalid format. Interesting. So let's do one thing. Okay. Let's go back. And let's take some locations. For example, what should we take? ITPL. Find. Is this ITPL? This is the location of ITPL. Okay, this is in Bengaluru. Okay, so let's take this latitude, longitude. Okay, let's see. This is 1 latitude and this is longitude. Okay, let's get some nearby location to ITPL. Send it. Nearby location to ITPL can be, let's say, what is this? Hoodie Lake. Okay, let's get Hoodie Lake. Find. This is Hoodie Lake. Right. Hoodie Lake is nearby ITPL, right? Oh, this is where? This is which country, man? Doesn't look India. Yeah. Oh, this is something else. Let's say VR Mall, Bengaluru. Yeah, this is definitely Bengaluru. But this is JP Nagar. Oh, this is the other one. No. Whitefield, Bengaluru. Finding latitude, longitude is pretty hard, man. Yeah, this one is VR Mall. And is ITPL and VR Mall within 5-kilometer range? This is also not VR Mall. Is this a right website? Is this VR Mall? This is not VR Mall. Okay, let's maybe go to something like Gemini. I guess they can help us. Can you please give me latitude and longitude of 3 locations of Whitefield, Bengaluru? Maybe the malls. Let's see. Oh, pretty good animation. Google is gonna die soon. I'm asking it latitude and longitude. It's showing me the location, man. Latitude and longitude, I'm asking. Okay. Unfortunately, I can't provide this. Park Square Mall we have. Okay. This looks like Park Square Mall only. Right. So. Okay. Akash has given us for Nexus Shantiniketan also. So we will add that as well. These are all nearby locations within 5-kilometer range. Okay. These are all nearby locations. Oh, one mistake I made. Let's make it driver ID 2. Okay. I made one mistake. I was adding just for one driver. This should be for driver ID 2. Send it true. Now for driver ID 3, let's take Nexus Shantiniketan's location from Akash. Pretty accurate, looks like. This is latitude, this is longitude. Now, can anybody give me something like latitude and longitude of Kempegoda Airport? Okay, let's give me lat and long of Kempegoda Airport. This is definitely more than 5 kilometers. Yeah. Okay, this is Kempegoda Airport. So now there is a driver number 4 on Kempegoda Airport. Copy, paste. Okay, send it. So we have 4 drivers as of now. Now let's make one more request and I'll save this. Let's add one more request, add request. And the URL should be nearby drivers. Okay, copy nearby drivers. And in the request body, we need to send a latitude and longitude. Okay, raw JSON latitude longitude. Okay, now can anybody give me some latitude and longitude of, okay, let's do one thing. Give me latitude and longitude of Hudi metro station. Okay, let's say our passenger is standing at, okay, they cannot provide Hudi. One second. Lat long finder. Let's say Brigade Lakefront, Whitefield. I didn't find anything. Oh, your daily quota is over. Oh, great. Okay, so we have from Hudi Circle, we have a lat long of Hudi Circle with us. Oh, we have for Park Square Mall. Let's take for Park Square Mall. Okay. Where is Park Square Mall? Is it in Whitefield? I live in Whitefield. I don't know. Is Park Square Mall in Whitefield? Yeah, it's in Whitefield. Yeah. Sorry, man. I don't like roam around a lot. But okay. Cool. Let's see. Okay. Let's see what are the nearby drivers we are able to find. Let's make a request. Can you see we are able to find 1, 3, and 2, and the driver number 4 is not coming up. Did you just realize? Because driver number 4 is standing at Kempegoda Airport, and that's beyond 5 kilometers. Okay. So this looks like working. We can do one more test. Do you guys want to do one more test, or do you guys think this is good? What do you think? Should we do like one more test? Or one thing that we can do, one interesting thing that we can do is, let's increase the radius from 5 kilometer to 100 kilometers. Then ideally all the drivers should come up. Can I say that? If I send it now can you see all the 4 drivers are coming up? Looks good, fairly good. We are now able to find nearby drivers. Are you guys able to get this point? Pretty simple, but easy. Isn't this one of the coolest thing that we have done in this whole project? And can you see the amount of code that we were expected to do was negligible altogether? And once problematic thing, don't you think that we have too much business logic inside our controller? Shubham is saying one location for one driver. Shubham, it's a cache. Redis works on caching mechanism. That's a key value pair based cache. So there are always unique keys. And the key here is driver ID. So for one driver, there will be always one location only. If you send one more request for the same driver, it will update the old location. Are you able to get this point, Shubham? It's kind of like a hash map. Okay. Guys, technically we should introduce some services, right? I'll just very quickly do that. Redis location finder service. I'll mark, and technically it should not be a, one second, I directly made a class. I should technically delete this. I'll first of all make a new package, services. First of all, we should make an interface. Okay. Location service interface. Inside this interface, we are going to expose a couple of things, right? The first one, that is to save driver location. So we should technically return a Boolean save driver location. Are you able to get this point, everyone? And what should be the arguments? What should be the arguments? To save the driver location, what do you need? You just need the driver ID, latitude, and longitude. So I'll say string driver ID, double latitude, double longitude. Are you able to get this point? Longitude. And the other one, we should get a list of, and what we can do is, let's this time now have a location also. Instead of just sending a list of string, let's send something else. So what I'll do is I'll make a DTO. I'll create a Java class. I'll say driver location DTO. Okay. And how the driver location will look like? It will look like this only. Okay. Driver location DTO. And inside the location service, we should technically return a list of driver location DTO, get nearby drivers, and the argument should only have latitude and longitude. Make sense, everyone? This should be the service. Right. And now for this service, we are going to write implementation. I'll say Redis location service implementation. It should technically implement location service, and we should have all the methods implemented. Okay. And here I'll get the data from my controller. We don't need the search radius and everything here. I'll bring everything now here. Okay. And now this as well, we should copy and paste here. Okay. And we should just pass the driver ID, just pass the latitude, and just pass the longitude. Longitude. Make sense, guys? And we need a string Redis template. So we will bring string Redis template, copy, paste, and this should be the Redis location service IMPL. And we should mark it with @service. Getting my point, guys? Okay. And you can see at last we can just return a true. Okay. And here, ideally, what we should do is we should copy this thing as well. Copy, paste it here. And now we don't need this. We'll just say latitude. We don't need this. We'll just say longitude. Okay. And this is coming up here. Now we don't need list of string of drivers. We'll say driver location DTO. Okay. And I will say driver location DTO driver location is equals to driver location DTO dot builder dot build. And I will pass this one here. Now I should say dot driver ID is going to be result dot get content dot get name dot latitude is going to be result dot get content dot get point dot get x. Get x is going to give you the latitude, and longitude is going to be result dot get content dot get point dot get y. Are you able to get this point? So you can see this content object, right? You can see this content object has a get distance. A lot of lot of properties you can see it has, right? So for now, we'll just keep this and we'll return this, return drivers. Okay. And from here, now we do not need string Redis template. Instead, what do we need? We need a location service object, location service, location service object, location service. This dot location service is equals to location service. Now we don't need to do any of these. We will say Boolean response is equals to location service dot save driver location. We'll pass the driver ID from get driver ID, latitude from get latitude, longitude from get longitude. And whatever is the response, we'll give the response here. Same thing we will do here as well. I'll say list of driver location DTO. We're also going to return driver location DTO. Drivers is equals to location service dot get nearby drivers, get latitude, get longitude. And that's it. Make sense, everyone? This should be the ideal case for us. Okay. Let's try again. Let's see if the service is up and running or not. Service is up. Now, if I try to make the same request this time, okay, it says internal server error. Oh, why is that? Let's see what happened. E dot get message. Okay, something went wrong. Send it. Okay, so the point is coming as null. Oh, 1 second. Why the point might be coming as null? Just a second, guys. Let's see. Let's do one thing. I'll do s out of result.getName. Okay. Send it again. 500 internal server. Okay, we are just getting one driver. Okay, driver with ID 1 we got. Okay, driver with ID 1 we got. This point is not coming up. Let's see why this point is not coming up. So get point. Let's print point once. Point is coming null. Let's do one thing. Okay, let's just send the name. Let's see if the normal API is working or not. Okay, so API is working fine. API is working fine. And you can see 100 kilometers. If I make it 5 kilometers, this is working fine. The point is coming null. Let's just rectify that. You can see now 5 kilometers. The point is good, but this get point is coming null. This one. Let's see why this is coming null. Okay, I believe what we can actually do is we can say double latitude is equals. Let's create a new point object, like maybe fetch instead of doing the get point. we can do geoops dot position. That means find for this particular driver. Okay, and we'll pass the geo key as well, driver ops geo key. Let's get this as the lat. Okay. Required type is double. This is going to give a list. Okay, one second. So this should technically give us a position. Okay, yeah, this gives us a position. One second. We are getting a list of position. Why is that? Just a second, guys. Let me see what is the problem here. We have the result.getContent.getName. What is the get name? This is just the driver ID, right? Let's see the position function. It gives a list of point for one or more members. Okay, we can pass all the members. Okay, got it. We can pass all the members. But ideally, this should also give us for one member also, right? So let's do one thing. So this should be dot get 0. Okay. And what happened now? Oh, this should be point, not position. My bad. Point. Okay. And now we can say, let's call it as point dot get x, point dot get y. Let's try it now. Okay. So now what I've done is I'm querying the cache only. I'm querying the Redis cache only, passing the driver key and getting its point because that's a nearby driver, right? So if now I send it, now you can see now we are able to fetch it. Probably this get content doesn't directly return us the things for the point. So we have to fetch the point directly. And you can see now we have point for each and every individual driver. And you can see they have different latitude points. If I change it to 100 kilometers and restart, and send it. Now, in fact, what technically should happen is that maybe you can also pass the kilometers that you want to find, right? You can also pass the kilometers that you want to find. So instead of having this as a fixed value, maybe in the request, the API request only, you can configure the distance. Are you able to get this point? Everyone, is this point making sense? Yeah, yes or no in the chat. Okay, and now you can see we have properly used all the polymorphism concept. You can see this is now a location service. Like we have all the solid principles and everything working end to end absolutely fine. Got it, guys? Anybody having any questions? So now, at any point of time, if anyone raises a booking request, we can find the nearby drivers and then we can maybe shoot some information to the nearby drivers, right? We can shoot a request that, hey, all nearby driver, this is an upcoming request. And whosoever is the driver who selects it first should be able to get the request up and running. Got it, everyone? Any questions from anyone? I'll just push this much code. Oh, it's not a Git repo, so Git init. Added Redis location service. Git checkout -b, GitHub. Uber project, location service, Git repo. And why I have not added message queues here? Because Redis is already a pretty fast DB because being a cache. So it doesn't need any internal interaction because this is already a pretty fast mechanism to go for. Got it? How do we handle the scenario when there are no drivers in the radius? How do we increase the radius? By making a request. So Akash has a fair point, and I believe that's a simple, more like a DSA kind of a problem. Just think about it. You can write a recursive logic based on which, let's say, initially you start with 5 kilometers. You start with 5 kilometers. If the list that you have stays empty, right, then what you can do, then you can recursively call this same method with 10-kilometer radius. Then you can recursively call this method to 15-kilometer radius, and you can keep on recursively calling for, let's say, till 25 kilometers. And if till 25 kilometers you didn't find anything, you'll return empty response. Otherwise, at any point of time in between you found something, then you can return that. So you can write a recursive logic, Akash, right? Everyone say yes or no in the chat. We can write a simple recursive function, right? I hope that much amount of DSA everybody knows. Isn't it? Or if you don't want to write recursion, then you can have another method. Like you can move all of this logic to a helper method. In that method, you can have a for loop for 5 kilometer, 10 kilometer, 15 kilometer. Every for loop will call this function. If this function keeps on returning empty list, you keep on moving forward in the for loop. At any point of time, if this for loop this function returns something, you break the for loop there. That can also be one logic that you can add. Any questions, anyone? Nobody has any questions? Okay. Now, because you guys didn't make much of an effort for Redis, I want you guys to at least make an effort for Mongo. Okay. You already know MongoDB and everything. And I talked about this architecture, right? So this Redis service we have up and running. I want you guys to write one more Mongo service, Mongo location service. That's what that is going to do. That's going to just add the incoming request to the message queue. And then that message queue is going to later populate the MongoDB with a consumer, right? That message queue, you can use anything. You can use even Redis message queue. You can use, let's say, Kafka. You can use something like RabbitMQ. Anything you can use. Got it? I want you guys to make some effort here. Everyone, are you guys able to get this point? I want you guys to make some effort here. Okay. And in the next class, maybe we can, then I will discuss and implement. Okay. Currently, what I want to talk about is I want to talk about something called as WebSockets. Okay. That's also an important part of an architecture. Now, currently, what happens in the current architecture is that every time there is a client, it makes a request to the backend. Backend processes the request and sends back a response. It's a request response lifecycle altogether. Okay. It's kind of like this request response lifecycle is more like, let's say, sending letters to somebody. That you are sending the letter to somebody, it takes some time for them to receive it. Then they read the letter, then they write the response letter back, and then give you back. But nowadays, we do what? We are having a phone conversation as well. In phone conversation, both of the people can talk at the same time. You don't have to wait for the other person to say something first and then only you will say. You both can say everything at the same point of time. Can I say that? Okay. So this kind of an architecture is more like a pipeline-like architecture, where let's say you have machine M1 and you have another machine M2. Okay. And these machines are not waiting for anybody's request to give a response. Instead, they have kind of like a pipeline. They have kind of like the pipeline. And inside this pipeline, at same point of time, anybody can send the data to any side. Like at the same point of time, M1 can also send data to M2 and M2 can also send the data to M1. And that too in a reliable fashion. If you have to send data in a reliable fashion, what does that mean? You need a TCP connection for reliable data transfer, for reliable transfer. Okay. So this kind of an architecture where you use TCP connection for a reliable data transfer And the data transfer is not based on a request response lifecycle. Instead, it is a pipeline based mechanism where at the same point of time, both M1 and M2 can actually send the request and response back and forth without waiting anybody else to initiate the request or anybody else to send the response. This whole mechanism is actually called as WebSockets. This is called as WebSocket. Are you guys able to get this point? Okay. So you can say WebSockets is again one more protocol, just like HTTP, based on TCP. But what's the difference? The difference is that this is more like a pipeline-based seamless communication, right? Once the connection of WebSocket between two machines have been set up, they can seamlessly send the request and receive the response without any issues altogether. Yes, at the same point of time, both can send request, both can receive response. Now I'm going to say something very opinionated. I'm not sure how many of you guys will agree with this. And I don't even want you guys to agree with this, to be very honest, because it doesn't matter. To implement WebSockets, by far as of now, what I know, the most simple implementation is available in only two languages. One is Python, and another one is Node.js. Node.js, of course, is not a language, but you can say JavaScript as the language and Node.js as the runtime. Okay. They have by far the most simple APIs to actually interact with WebSockets, to be very honest. And in fact, Node.js has a very famous library called as socket.io also. Socket.io makes things go on a next level simplicity. Are you able to get this point? Okay. Now, but we are neither using Python nor we are using JavaScript. So if you go to other platforms like, for example, Ruby with, let's say, Rails. So Rails has something called as Action Cable. Okay. Action Cable internally implements WebSockets, and the API for Action Cable you will find pretty different than if you have worked with socket.io. These things might look an overkill to you because more or less they implement things in kind of like a publisher subscriber kind of a model. Similarly, in Spring Boot, unfortunately, you don't have a very simple library like socket.io. Are you guys able to get this point? We don't have a very, very simple kind of a library like socket.io. Instead, Spring Boot also is able to implement sockets, but again, in a more like a publisher subscriber kind of a way, right? The functions and the APIs that are available to us is more like a publisher subscriber kind of set of APIs. Are you guys able to get this point? Say yes or no in the chat. So one thing to note, in Spring Boot to implement, like if you know JavaScript, I would highly recommend you to always implement sockets with JavaScript. It's less time consuming and it's more fun. If you don't know JavaScript, then whatever is your tech stack, you have to do it in your tech stack only. We will be implementing it in Java, of course. I don't want to go to JavaScript, but I'm just giving you recommendation. And that's why I said this is all opinionated. Are you able to get this point? Say yes or no in the chat. Okay, so let's see now how exactly Java-based ecosystem helps you to implement WebSocket. But before we go there, just for a definition, what is WebSocket? It is a protocol. It is a protocol that allows us to implement bi-directional communication. Make sense, guys? WebSocket helps us to implement bi-directional communication. Okay. Interestingly, WebSocket is also based on TCP and HTTP is also based on TCP. Okay. When you're setting up a WebSocket connection, then to set up this pipeline for the very first time, WebSocket also uses an HTTP connection only. And later that HTTP connection is upgraded to a WebSocket connection once the pipeline is set up. Are you able to get this point? Somnath, what I'm saying is that this is your pipeline. Okay. What we are referring this to. This is technically your pipeline. Through this pipeline, you can exchange data. Now to we have to set up this pipeline for the very first time between M1 and M2. And after it is set up, then you can send and receive data bidirectionally. Now to set this pipeline up, WebSocket first uses an HTTP connection only to set up this pipeline, because now M1 and M2 have to communicate for the first time. First time communication is like a request response only. So M1 and M2 communicates with each other in a request response handshake. And then this pipeline is set up. Once the pipeline is set up, then there is a seamless, I would say, exchange of data between M1 and M2. Are you guys able to get this point? Okay, so I can even write it here that for the first time pipeline setup, WebSockets use HTTP, and then the connection is upgraded. Are you able to get this point? Say a yes or no in the chat. Now, in this pipeline, the message that you send generally doesn't have any specific format, because eventually the message is converted into like bytes, and those bytes are actually transferred altogether. Like, it's not like a REST protocol or something that you have a specific defined JSON only that you have to send. You can send anything altogether. Are you able to get this point? Okay. Now, generally, wherever you go to languages like Java, at any point of time, if you don't have dedicated types, then again, things starts breaking. So that's why in Java, to implement WebSocket, there is slightly kind of like a second route that is available. Okay. Now, what WebSockets allows us to do is, WebSockets says that if you want to use WebSocket, you can use, let's say, some other protocols on top of WebSockets, which are more accessible for your ecosystem. And then internally, still WebSockets will work, but you will interact with those higher level, I would say, protocols. So what WebSocket says is that internally, you will be using WebSockets, and internally WebSocket use TCP. But on the outer layer, you can use some other protocols, some other higher level protocols. And your ecosystem, let's say your corresponding Java code, let's say your corresponding Java code is going to actually interact with these higher level protocols. And internally, these higher level protocols are going to use WebSockets only. Are you able to get this point? सौरभ उसी पे आ रहा हूं मैं, डोंट वरी, उसी पे आ रहा हूं. ऑल्सो गाइस, क्लास का नाम देख के मत आया करो प्लीज. मतलब ऐसा हो सकता है ना कि कुछ पुराना पेंडिंग हो, वो कराए बिना मैं आगे नहीं बढ़ सकता ना. डोंट वरी, ठीक है. Is everyone able to get this point? Now, you might be thinking why I'm talking about all of this. Why I'm talking about all of this? I'm talking about all of this to introduce something that is pretty important for our application. That is microservice, or I would say inter-service communication. Okay. Now, what is inter-service communication? In inter-service communication, what we mean is that we have, let's say, one microservice, service 1. And let's say we have another microservice. We have another microservice, service 2. Okay. So let's say we have two microservices altogether. Now, let's say we want to exchange some data between these microservices. We want to exchange some data between these microservices. How can we do that? So technically, to exchange data between these microservices, there are two ways. There are two ways. Okay. One way is synchronous communication. Another way is asynchronous communication. Are you able to get this point? Somnath, I'll talk about what is those higher level protocols. Okay. You can say some protocol for now. Now, what is a synchronous communication? In a synchronous communication, what happens is that, let's say you have a service S1, and you have a service S2. What they're going to do is they're going to communicate with each other using some kind of an API call, with, let's say, some request response infrastructure. Now, this API call can be a REST API call. It can be a gRPC call. It can be anything. In fact, it can be a WebSocket call as well. Are you able to get this point? So what S1 is going to do is, it's going to, let's say S2 is going to expose some API in its controller. S1 is going to make an API request. Maybe if you're using Java, then you can use retrofit. Remember, I made you guys use retrofit very early. So maybe you can use retrofit to make an API call to S2, right? Remember, we were using retrofit to make an API call to that JSON placeholder. So you can say JSON placeholder is one microservice for us. JSON placeholder is one microservice for us. Okay. And what do? We make a REST API call, maybe an HTTP REST API call, or maybe you can make a gRPC call. You can do something. Got it? This is a synchronous communication. Why synchronous communication? Because when S1 is requesting data from S2, S2 is going to wait for the response. While the S1 is going to wait for the response till the time S2 processes the request and sends the response back. Whereas there is another way called as asynchronous communication. In asynchronous communication, what's going to happen is that, let's say S1 is going to request some data from S2. S1 is going to request some data from S2. Now, we know that S2 can take some time to get that data back to us. So we are not going to wait for S2 to come back. We are not going to wait for S2 to come back. We'll just trigger the request to S2. And after some time, let's say after 30 minutes, S2 has that data ready. Then now what S2 can do is, S2 can send that data back to S1. But now you might be thinking, sir, for 30 minutes, we don't have an HTTP connection open, right? So what you can do is, you can have a WebSocket connection open in between them. If you have a WebSocket connection between them, then without S1 requesting for the data, S2 can send the data back. Are you guys able to get this point? Because it's a seamless connection. Or S1 can do long polling. Long polling means you periodically make HTTP API request. Like after every 5 minutes, you are saying, hey S2, do you have data? Hey S2, do you have data? Hey S2, do you have data? And so on. And the third way can be, let's say you have a message queue in between. You have a message queue in between. What S1 will do is, S1 will initiate the request to S2 and sit back tight. Now what S2 will do is, whenever S2 has the data ready, S2 will give that data to the message queue and become the corresponding producer. And inside S1, inside the microservice S1, we are going to have a consumer return that is going to keep on looking inside this message queue. And the moment S2 puts that data, maybe let's say after 30 minutes, S1 is going to pick that. This is again an example of asynchronous communication, because S1 is not going to wait for the data to come up. Are you guys able to get this point? Say yes or no in the chat. And in our application, where do we need it? Let's say you have a booking service. Right. Now, booking service is going to make a request. Booking service is going to make a API request to your location service. And this request is going to be a asynchronous communication. Sorry, this request is going to be a synchronous communication to fetch nearby drivers. Are you able to get this point? To fetch the nearby drivers. Yes or no, guys? Yes or no, guys? Okay. Now, let's say you have a couple of drivers. So let's say these are driver apps. Okay. This is, let's say, driver D1. This is, let's say, driver D2 app, driver D3 app. Okay. Now what we are going to have is, we are going to have a booking request service. Booking request service. Okay. What this booking request service has to do is, our booking service is going to make a asynchronous API call here. We are going to make a async communication here. Why? Because now we have the details of the drivers. Now we need to send the request to those drivers, and whosoever accepts our request, we will get the data about that driver back. So drivers can take 5 minutes to accept the request, 10 minutes to accept the request, or maybe we never find a driver. We never find a driver who accepts the request. Are you able to get this point? Okay. So this booking request service is going to probably open some WebSocket connections. It's going to open some WebSocket connections with all the driver apps, all the nearby driver apps. These are going to be your WebSocket connection. I'll write it as WebSocket. In this WebSocket connection, it will ask, hey driver, this is the booking coming up and this is the amount of the booking. Do you want to accept it? Right. And then whichever driver actually accepts the request, let's say this driver accepted the request, this booking service is going to asynchronously give the, this booking request service is going to asynchronously give the response back to the booking service. Maybe for that, we can maintain a queue. Maybe for that, we can maintain a message queue. Okay. So inside this queue, what will happen is this booking request service will tell that, okay, this driver has accepted our request. And we will write a producer for it. And then booking service is going to write a consumer that is going to keep on checking that, okay, whether this booking with ID, let's say XYZ, has a driver allocated or not, has any accepted the driver or not. And once you have it, you have your booking status updated. How many of you guys are able to get this point? Say yes or no in the chat. So this dedicated I would say service we are going to keep for all the open WebSocket connection for the client. Make sense? You can say booking request service, or you can just call it as client socket service. Let's call it as client socket service. Sure, Somnath, please ask. How many of you guys are able to get the point what I am talking about here? How this part of the architecture is working? Okay. And on the other side, if you see the clients, like the passengers, okay. So let's say we have a passenger P1. The passenger P1 also somehow, after, like, I'm assuming that you have auth and everything done. This is also going to open a WebSocket connection with your client socket service. Once this WebSocket connection is open, P1 is going to request for a ride. This client service is going to initiate a request to the booking service that, hey, booking service, what do we need? We need a new booking. So it will create the booking object, right? And this communication can also happen maybe in a async way. Okay. Now booking service will fetch the nearby drivers, get the nearby drivers, then using this client socket service, initiate request to those drivers. One of the driver will accept it. You are going to put it in the queue. You're going to consume it in the booking service. And now you have a booking ready. Once you have a booking ready, what you can do is you can use maybe another queue, or you can use the same queue. For now, just for demonstration, I'm using another queue. Okay, another message queue. And now this booking service is going to produce a message in this queue that, okay, a new driver has been allocated. And we are going to have a consumer here in the client socket service that, okay, this has received the response. And then using this WebSocket connection, I'm going to send the response back to the viewer. So this kind of an architecture we can actually set up. WebSocket we only use for chat purpose. No, it's not. That's not, first line is not true. We should not say we only use for chat purpose. WebSocket has a lot of purpose. For example, if you see your social media apps, you see notifications there, right? Without refreshing the page, you see notification that somebody liked your post. It's WebSockets. Are you able to get this point? So it's not only for chat. Now, remaining message. WebSocket we use for chat purpose for building connection, means accepting request, or we can send request from client to driver. Somnath, WebSocket is a protocol. Once this WebSocket pipeline is set up, you can send and receive anything. The only difference is nobody has to initiate a request to get a response. You can just sit back tight and anybody can send you a request, anybody can send you a response. It's kind of like a telephone. Both of the people can talk at the same point of time. Whereas in normal HTTP request or in a normal letter, somebody sends a letter, you're going to wait for that letter, and then you are going to send the letter back, so on and so forth. It's kind of like that. Make sense, Somnath? Somnath, concept, what is the concept? Like concept of producer consumer is simple. Producer consumer means that there is going to be somebody who is going to create the data, and there is going to be somebody who's going to consume the data. So there's going to be somebody who's going to create the data in the queue, and somebody who's going to take that data from the queue and use that data. Are you able to get this point? That's the simple concept of producer consumer. You can read about, there's a very famous problem called as a producer consumer problem. If you are in BC or BTech or BSc, you will be definitely introduced with this kind of a problem. Okay, this is like, it's a pretty complex problem, but you will get the concept of the top, like you will get the concept of who is a producer and who is a consumer. Okay, read about this problem. Like if you're in BTech, it is part of your syllabus also. Got it? Everyone, makes sense? So that's why I introduced WebSockets, and that's how inter-service communication happens. Anybody having any questions? Because we are going to come back to WebSockets as well. Anybody having any questions? Anybody having any questions? No questions? Okay. Now I was talking about WebSocket and the higher level protocols, right? That WebSocket says that you can use some higher level protocols on top of WebSockets, and maybe your ecosystem can interact with those higher level protocols. One of those protocols that is supported by Java ecosystem is Storm protocol. How many of you guys have heard about Storm protocol? Okay. So you can see Stomp is nothing but a kind of like a text-oriented messaging protocol, right? It's a text-oriented messaging protocol. How Stomp looks like is this. So if I go to these images, you can see this is kind of like a typical architecture for a Stomp protocol. Internally, Stomp protocol is also kind of like a publisher subscriber protocol, right? It uses some simple messaging queues and messaging brokers, right? Okay, first of all, you might be hearing this term a lot, message brokers. Okay, message broker. You can say message broker is a computer program that translates a message from the sender's formal messaging protocol to the receiver's protocol. Okay, so in simple terms, whenever I say message broker, then you can say message broker is the whole software that manages the message queues, right? It has event listeners, it has capability to create a producer, it has capability to create a consumer, end to end. Are you able to get this point? So when you say MongoDB, you're talking about the whole MongoDB database. It includes the MongoDB server, it includes the query creator, it includes the optimizer, query optimizer, all of these things. Are you able to get this point? So you'll hear this term message brokers a lot. So what you can do is that using Storm, the clients and the two end-to-end clients can actually interact using these message brokers. Are you able to get this point? And the best part is that if, let's say, one client is built up in, let's say, C#, another client is built up in Java, they can still talk to each other, right? Are you able to get this point? So you can, for now, what we have discussed is WebSocket is a pipeline-based connection. On top of WebSockets, you can use some other protocols, and one of them is Stomp. Stomp is a text-based messaging protocol, right? And using Stomps, two clients which are written in absolutely two different languages, maybe one written in Java, one written in C#, one written in Go, can actually communicate with each other. Are you able to get this point? Are you able to get this point? We'll go step by step in Stomp, but first of all, this basic about Stomp is making sense to you? I have heard too, microservice can communicate in, but Saurabh, that's not related to Stomp. Saurabh is saying microservices can communicate with different languages. This part is not related to Stomp. Just think about it. If this service S1 is written in Python, this service is written, S2 is written in Spring Boot. Both of them are going to expose HTTP APIs, right? So it does not matter what language service S1 is written in, does not matter what language service S2 is written in, they can still communicate because the communication is happening over the network. You have to just make an API call altogether because you, okay, do you know what JSON API holder.com has made their APIs in? Do you know whether it's a JS API, it's a Python API? Like, no. JSON is the response that they are sending. JSON is not a programming language, right? Saurabh? Yeah, we don't, because we don't care. One service communicating to other service doesn't care what is the language, because that's language agnostic. You are connecting through either APIs or maybe in an asynchronous way. One question from previous architecture. If you implement with MongoDB, message queue between broking service and location, it will be as yes, you're right. Because currently I have implemented Redis, right? अभी तक तो मैंने खाली Redis ही implement किया है. So that's why I said asynchronous communication. वास्तव अभी मैंने खाली इसे Redis कर रखा है ना implement. और Redis तो Redis हम लोग synchronously कर रहे हैं. उसने लिखा है, तुम इसको change कर सकते हो बाद में, no problem. Anybody else having any questions? Okay. No, because you can see ना, in Redis मैंने कोई queues वगैरह कुछ introduce नहीं किया ना. API कॉल आ रही है, Redis में हम लोग स्टोर कर रहे हैं और immediately response भेज रहे हैं. Okay, cool. So if you want to set up this Stomp protocol, if you carefully see how this Stomp is actually working, right? If you just give a simple look, I'll talk more about this architecture. You can see there is some kind of a client message. Can you see there are dedicated client messages that you are going to send through some kind of channels, right? And like you can see, you can send a app news, you can send a topic news. You will be having some controller methods, and this message broker is going to receive that and send it back to the other set of clients. Are you able to get this point? Okay, so I'll talk in more detail about how exactly this whole architecture is working. But for now, you can understand that Stomp is a text-oriented messaging protocol. It provides interoperable wire format so that Stomp client can communicate Stomp clients can communicate with any Stomp message broker to provide easy and widespread messaging among many languages, platforms, and brokers. Are you able to get this point? Stomp is very simple and easy to implement protocol coming from HTTP School of Design. The server side may be hard to implement, but it is very easy to write a client to get yourself connected. Okay. So a few things you have to set up on the server, but once done, things are going to be super easy for us. Are you able to get this point? So what I'm going to do is I'll come up here. I'll maybe prepare a new project and I will name it as client socket service. Okay. I'll click on next. Okay. And now in order to set this up, what do we need is we need a Spring Boot starter WebSocket. So can you see WebSocket? If you search for WebSocket here, you can build WebSocket application with sock.js and Stomp. Can you see sock.js and Stomp? Okay, so that's the same Stomp protocol that I'm talking about. Are you able to get this point? Okay, so I'll just use WebSocket here, and you can see it has also opened the documentation for us. Okay, using WebSockets to build an interactive web application. Can you use that? You can see you have to define the message type, that what is the type of the message that you want to send. Okay. And you have to create a message handling controller. You can see very similar to REST controllers, right? Very similar to REST controller. You have some kind of a mapping, you have some kind of a topic, and then on that topic, you can actually send some messages altogether. So we're going to set up all of this. We are going to set up all of this. And you have to also set up the configuration of the message broker altogether as well. So we're going to do all of this. We're going to do all of this, right? Step by step, I'll also explain how every step of the WebSocket part works. Okay. But apart from that, I don't think we need anything else. We'll just click on create. And I'll open it in a new window. Make sense? And if you go to your build.gradle, you can see we have a Spring Boot starter WebSocket. Can I say that? Why are we using socket here in our application? Okay, that's a fair question to ask. Although we already have the answer for that. Okay. Somnath, just think about it for a moment. Sorry, not Somnath, Saurabh. For a moment, think about Saurabh. I'm a driver. I'm just riding my car on the road somewhere, maybe in Bengaluru. Okay. I have my Uber application open, but I'm not doing anything. I'm just driving my car. In between driving my car, I get a notification that there is a new ride coming up. Do you want to accept it? Now, my both hands are on the steering. So I cannot do any activity on the app to raise a request for getting a ride. The app is already open. It automatically sends me a pop-up that, hey, there is a new ride. Do you want it? I'll say no. And I keep on driving. Then again, it says, hey, there is a new ride. Do you want it? Are you able to get this point? What's happening here? I'm not introducing push notification because, again, push notification can be very specific to mobile. Let's say you have a laptop open. No? Let's say you have a laptop open. Then also this can happen, bro. Now, you have not raised any request to get a ride, but you still get a pop-up that, hey, there is a ride. Do you want it? There is a ride. Do you want it? And so on. How will you achieve this? One way to achieve this is that from your mobile app or your laptop, I do a long polling on the server. What is long polling? In long polling, you periodically hit the server that, hey, server, do you have a new ride that I can take up? Hey, server, do you have a new ride that I can take up? Hey, server, do you have a new ride that I can take up? And so on. But just think about it. Uber has 10 million drivers, maybe. Sorry, 3 million drivers, maybe. If all of those 3 million drivers keep on sending their ride request, your servers are going to be bombarded, right? How about instead of they asking you for a ride, you yourself tell them that, hey, there's a new ride. Do you want it? If they say yes, you allocate it to them. So for you, for me as a driver to not send a request and still get a pop-up, how can I do that without long polling? Another way is WebSockets. If I have a socket connection set up between my mobile app and my socket server, then I don't have to raise any request to get a response. The server can directly send us a response. Can I say that? That's why you need a WebSocket here. It's kind of like, let's say you and me are chatting. You and I are chatting, okay, on WhatsApp. I don't want to again and again close WhatsApp and open WhatsApp to load the new messages. I want to stay on our chat screen, and the moment you send me a message, it should automatically pop up on my end. It should not be required for me to refresh WhatsApp again and again. Are you able to get this point, guys? But this can be achieved through cron job and push notification. You will do push notification, let's say if you have a phone or something, no? Let's say even if you do web push notifications, don't you think how push notifications internally work? Right? And cron job, instead of a cron job, just write a periodic long polling, because cron job is what? Periodic scheduled jobs, right? That's not a suitable case for us, because that's similar to have a long polling altogether. Make sense? Okay, cool. So we have started setting up a new service. I believe we are already up time. Okay. So what I'll ask you guys to do is, please go through this documentation once before the next class. This is going to be super helpful. Okay. This is going to be super helpful because it's going to be a pretty different scenario to actually connect in WebSocket in Java Spring Boot. I know 99% of the time when you see sockets chatting and everything, people will only tell you socket.io and Node.js based sockets, worst case Python. Not a lot of people talk about Spring based, or I would say Java based socket connections. So we'll start working on our client socket service maybe in the next class. And you can see we have all the, I would say, gaps filling up. Now we have a location service ready. We have kind of like a booking service that we can very quickly prepare. It's just simple CRUD, nothing much. And once our client socket service is ready, things are going to start shaping up pretty well. Make sense? So the next class can be slightly heavy on content because we are going to talk about Stomp. And there is something called as sock.js. I'll talk about what is sock.js. It's kind of like the library that helps us to enable Stomp from the client side, but okay, we'll talk about it. Okay, just go through this. Just go through this documentation once, and then I'll explain what is a broker, why do you need a broker. I'll talk about the internal architecture for how exactly Stomp works, and then the whole communication is internally done by WebSockets. So that's going to be a simple thing that we are going to do. Make sense, guys? I'll share all of these diagrams on the group so that you have it for a reference. Till here we didn't microservice, right? Sort of all of these are individual microservices. I'm not sure where do you not have the clarity? All of these individual Spring Boot projects are individual microservices. Yes, the only thing that they have not done yet is inter-service communication. I have introduced inter-service communication today, and now they can, like, once we have this client socket service also ready, we can start setting up the inter-service communication. Are you able to get my point, Saurabh? All of these individual Spring Boot projects are individual microservices. Yeah, Eureka will come. Without Eureka also, you can do everything. Eureka has a very specific use case. Even if you don't use it, things are going to work absolutely fine. It's for service discovery. I'll talk about it's a very simple thing. That's not even the complex part. Yes, Somnath. Generally, it's requirement based. It's not required everywhere. For example, I don't see where in an e-commerce application you will require WebSocket apart from chat, like a basic e-commerce at least. Okay. Yeah, Shubham. That's why I picked this project, because in this project you have everything. You have messaging queues. Now you can see you have geolocation database. You have normal RDBMS coming up. A lot of things, and that's why I like writing these complex projects. So yeah, we'll try to implement the client socket service in the next class. Okay, I will follow you only until my microservice class finish, because I gone through a lot of Spring microservice video, bit confusing for me end to end. Yeah, don't worry. Like, I need once, and for starting the communication, Saurabh, I need to set up all the pieces on the plate. Once the pieces are on the plate, communication is very easy, because if you remember, you guys already know retrofit. Or without retrofit also, there is something called as REST template builder. If you want to like use something very simple. So REST template builder is very simple. Okay. You can make calls from REST template builder. It's very, very simple. So like overall, like, you know, most of the pieces of the puzzle, last piece of the puzzle is left. Once we are done with that, the communication is going to be pretty simple. Make sense? Okay. That being said, let's wrap today's session here, guys. Your network and the LLD, the two design pattern lectures should be up by today. Akash, I just shared you, right? I just shared you the docs. Just use that. I'll share that on Discord as well. Okay. We'll meet soon in the next session, guys. Till then, take care. Bye-bye. Have a really lovely week ahead and keep coding, everyone.